Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Have you ever wondered why child development feels so unpredictable, like a sudden burst of language or a random change in how a toddler acts? We usually try to measure these things like a straight line. But a brand new way of looking at human growth suggests that kids might actually be developing like a weather system. When we look at typical theories from the past, like the work of Piaget, they made it sound like every child goes through a set of steps in a specific order, almost like climbing a ladder. You reach level 1, you finish it, and then you move to level 2. But in reality, development is messy. Some days a child seems to have learned something new, and the next day they seem to have forgotten it entirely. This weird, up and down, unpredictable path is exactly what the authors of this paper want us to consider through the lens of chaos theory. Now, don't get scared by the word chaos. To a scientist, chaos does not mean total disorder or a room full of toys scattered everywhere. Instead, it refers to systems that are very sensitive. Think of the butterfly effect as the idea that a tiny flap of a wing in one part of the world can eventually lead to a giant storm somewhere else. If we apply that to kids, it means that very small differences in how a child's brain or body starts out can lead to massive differences by the time they reach school age. The paper argues that we should stop thinking about development as a smooth ramp and start thinking about it like a landscape with valleys. Imagine a marble rolling down a hill. There are certain grooves or valleys that the marble naturally falls into. These are called attractors. They represent stable skills or behaviors that a child sticks with for a while. The big insight here is that a child often stays in one of these valleys, maybe acting a certain way or using a specific strategy to solve problems until they hit a fork in the road. In math, this is called a bifurcation. It is basically a tipping point. When a child accumulates enough new experiences or physically grows just enough, the system becomes unstable. The marble pops out of the old valley and rolls into a new one. This explains why we see those sudden explosions in language, or why a baby might suddenly figure out how to stand up after weeks of practicing shaky movements. It is not that they were just getting gradually better. They hit a threshold and the entire system reorganized itself. The authors suggest that this is actually a really healthy way to be. They talk about something called the edge of chaos. If a system is too rigid, like a computer program with cold hard rules, it cannot adapt when the world changes. But if it is too chaotic, it falls apart. The edge of chaos is that sweet spot where a child is stable enough to keep the skills they have worked hard to learn, but flexible enough to change when something new comes along. It is perfectly adapted for learning and growing. So, how do we study something this complex? You cannot just measure a kid once a year and expect to see these shifts. You need a lot of data. You need what researchers call high-density longitudinal designs. Instead of checking in every 6 months, imagine checking in every day or every week, tracking little details like how an infant moves their legs or how they babble. It is like turning a blurry, zoomed out photo into a crystal clear video. When we have that kind of data, we can use math to see if a system's behavior is about to shift. We look for warning signs, like when a child becomes extra fussy or their behavior becomes way more variable than usual. That variation is not just annoying background noise. It is actually a signal that a tipping point is coming. This changes everything for how we think about helping children who might be struggling. If you know that a child is stuck in a negative valley or an unhelpful pattern, you do not just need to push them with more of the same boring lesson. Instead, you need to deliver a targeted nudge at the exact right time, right when their system is at that critical sensitive point where it is ready to shift. It is like pushing a swinging door just as it starts to slow down. If you push at the right time, you get a much bigger result. Of course, this is not easy. One big limitation is that collecting this much data is hard for families and for researchers. It is expensive and takes a long time. Plus, we are still just learning how to build these complex computer models that can accurately simulate the life of a single child. But the potential is huge. By moving away from simple linear models and embracing the messy, chaotic reality, we can actually build a much more precise science of human growth. It allows us to treat every child as a unique individual whose path is shaped by their own starting conditions and experiences, rather than just a dot on a group average graph. I really love this perspective because it respects how complicated and unique every human being is. We are not just machines following a manual, we are dynamic, breathing, learning systems. The idea that we can find the math behind our own growth is both empowering and fascinating. It suggests that there is a deep order to even the most chaotic moments of childhood. I would love to hear your thoughts on this. Does it make sense to you that development is more like a weather system than a staircase? Let me know in the comments below. If you enjoyed this dive into the math of human growth, make sure to hit that like button, subscribe to RUBIN'S Mind Lab, and ring the bell so you never miss another deep dive into the fascinating world of human behavior. See you in the next one.